All right, we're going to explore expected value. One common question that you'll see in expected value is the game fair. So what we're going to do is look at the value of a situation, and basically if a game is fair, its expected value should be 0. So that way it's not in favor of the person playing or the person that's creating the game. In this case, it's not a game, but an exam that we're going to be looking at. And we have Maria. She's taking a multiple choice exam in which there are 5 possible answers for each question. The instructions indicate that she'll be awarded 2 points for each correct response. She's going to lose half a point for each incorrect response, and no points will be added or subtracted for answers left blank. If Maria does not know the correct answer to a question, is it to her advantage or disadvantage to guess and answer? What is your first intuition? So kind of think about that. What do you think is going to happen? Well, let's figure out exactly if it is to her advantage or not. So let's start by looking at the probability that Maria gets a problem correct after guessing. So in order to get one correct, it was a multiple choice question with 5 possible answers. So there are 5 responses that she could do for that question, but only one of them is going to be correct. So the probability is 1 out of 5. For incorrect, well, the other 4 choices would be incorrect, so the probability of choosing the incorrect answer is 4 out of 5. Now, what expected value really is that expected gain or loss of an event if the procedure happens many times. We compute it by multiplying each outcome by the probability of that outcome. Then we add up all of those. So let's think about this. How can you find the expected value if you guess an answer choice using the indicated point outcomes and probabilities you found above? Well, we know that if we are correct, we earn 2 points. So we're going to take the probability we're right times its value, or the outcome that we get. We would earn 2 points. Then the other thing that could happen, the other possible outcome, is that we end up getting the incorrect answer. If we are guessing, then we know that we lose on half of our points. So again, this is the outcome of being correct, and this is the outcome of being incorrect if we do our guessing. And those are the total possible outcomes. You can see that my probability is 1/5 and 4/5 add to 5/5, which is 1. So those are all the possibilities. And so we can calculate this. We're going to be 1/5 times 2 is 2/5. 4/5 times negative 1/2 is going to be negative 4 out of 10. But this is really 4/10 minus 4/10, which is equal to 0. So if she guesses, which is totally fine, the expected value of that is going to be 0. Now, if she doesn't guess an answer choice, so basically the same setup, we have 1/5 of the time, she's going to be, that is the correct answer, 1 out of 5 is the correct answer, and she'd earn 2 points. 4/5 of the time, if you choose the incorrect answer, you are not going to lose anything, nothing happens to you. And so combining those together, we get 2/5 plus 0, which is 2/5. So remember that we were talking about the probability and our outcome being 2 points here or being 0 points here. And so our expected value for this is going to be 2/5 points. So that's partial credit compared to the 0 up here. So those results answer the question, if Maria doesn't know the correct answer, is it to her advantage or disadvantage to guess? Well, she shouldn't be guessing because she's actually only going to expect to get 0 points. If she doesn't guess, she gets 2/5 the points. And so it is to her disadvantage to guess. She's not going negative, at least. But the expected value of 0 is less than if she doesn't guess. Because if she doesn't guess, that's when she gets the 2/5 points. All right, let's look at another situation. We have a raffle going on. There's 1,000 raffle tickets being sold for $1 each, so we have a little cost going on. one grand prize of $500 and 2 consolation prizes of $100 will be awarded. The tickets are placed in a bin, and winning tickets will be selected from the bin. Assuming the probability that any given ticket selected for the grand prize is 1 out of 1,000, right, because there's 1,000 raffle tickets. And the probability that any given ticket selected for a consolation prize is 2 out of 1,000. So those are some different outcomes. How much can Irene expect to win or lose if she purchases one ticket? Well, the possible outcomes, right? She could either win the grand prize, which is $500, but remember also that she actually spent $1, so she doesn't totally win. It's going to be $499. So we got to make sure that we consider her net win there. And then she could get a consolation prize, so that outcome happens 2 out of 1,000. And for that consolation prize, it's $200. Well, not $200, oops, it's $100. But again, she paid $1, so it's actually only $99 that we're looking at. And the other thing that can happen is we lose. So there's 3 places to win, and so if we subtract that from 1,000, we'd get 997. And when we lose that $1. So when you go to calculate this, we're looking at 1 over 1,000 times 499 plus 2 out of 1,000 times 99 minus 997 really out of 1,000. I just put the minus in the front here. And so when we do that, this ends up being equal to negative 300 over 1,000, which is really negative 0.30. Now we were talking about money here, so really we're saying that she's going to lose 30 cents for every ticket. Which, I mean, it's in favor of the person that is doing this game, this raffle. Now she's feeling particularly lucky today. She wants to determine how much she can expect to win or lose if she buys 10 tickets. Well, really, this expected value is what's happening in the long run. So we're saying that she's going to lose 30 cents for each ticket. And so if she's going to buy 10 tickets, we're really saying 10 times that loss of money, which is going to be minus $3. So we can expect that she would lose $3 total.